Hello and welcome to the first real part of the AI boss fight series where we use state trees, of course. In today's video, we're going to look at adding the boss to our world, importing the meshes we need, importing the special effects we're going to be using. We're going to use Paragon Rampage and the FX Variety Pack. These are both completely free online, you can find it, and I'll show you later where to find them, how to download them and get them here. It's really quick and easy. It's through the Fab Store and Epic Games, so it's official. You know, there are no viruses, I promise. We look at how to make an animation blueprint just to use these animations we get, how to set them up. We then create an AI controller with AI perception, so we can actually detect the player. We can see the player when he walks into our vision. As you can see, when we're stood behind this little block, the boss can't see us. He doesn't know anything about us, but as soon as you walk in front of the boss, he sees a player, detects them, and he sets his attack target variable. He has a variable called attack target, which stores a reference to our player once he sees them. We also create the state tree and add it to the base boss. We don't touch too much on the state tree because this video is really focusing on just the base ground foundations of the series. We don't really get into the boss fight and the state tree and the AI because we have to do the base things like importing assets we're going to use, setting up the animation, setting up the AI controller. This video is really just the base for the series, base for the course. But once you've got this one done, going forwards, we'll really get into a lot of AI features. So yeah, I hope you enjoy the video. I hope you enjoy the course. Yeah, thank you. Okay, so I've opened the Unreal project browser and I've gone to third person template. All the default settings, just call it boss fight, and we're going to create the project. Now that the project is open, we're actually going to close it straight away. We only needed to create the project so that we could then add assets to it, but we don't need to do anything yet. The first thing we're going to do is we're going to go back to our Epic Games store, our Epic Games launcher. We're going to go down into our Fab library. Now, I'm going to assume that you don't already have these assets downloaded, so I'm going to show you how to get the necessary ones for this project. Go to the Fab store on Start Exploring. It's going to take you to the Fab store, and then go to the search bar and then just search FX Variety Pack. We're going to import two assets. We're going to get the FX Variety Pack and Paragon Rampage, which is a character. So click on FX Variety Pack. It's very popular, very well known. It's completely for free. So just click Add to My Library. And the next one we're going to do is Paragon Rampage. So search for Paragon Rampage, click on the character and click Add to My Library, and we're all good to go. There's loads of Paragon characters and they're actually really cool. It's not just a character, but there's also animations, there's some special effects. It's really good. There was a game called Paragon that was in development. I don't know if it was released or not, but Epic Games basically just released a bunch of assets from the game for use. You can't redistribute the assets, you can't sell them as an asset themselves, but you can use them in your own games commercially. So I think that's really cool. There's also these Paragon minions. I really like the Paragon minions pack because it comes with a few different minions. But yeah, I'm not going to download them all for this course, just Paragon Rampage, but you should 100% check out all these really cool characters. As you can see, they're all free. Now go back to the Epic Games launcher, go back to our library. You might have to restart your computer to get these show up. I've already got them here because I had them installed, obviously. But if you don't see them now, just wait a little bit, restart your computer. Sometimes it takes a while for it to update. But when everything's good, search for FX Variety Pack, click Add to Project, and click on Boss Fight, the one we just created. As you can see, I've already done this project state tree boss fight. Add to your boss fight project, and then search for Paragon Rampage. Paragon Rampage, add to project, boss fight. There we go. Mine's gonna add really quickly because it's already in my cache memory. But for you, it might take a little bit longer. So just wait till that's all added, and when it is, open the boss fight project. Just double click, and let's open it up. Now, once our project is open, there we go, the first thing I'm going to do is delete this little center piece, right? Just get rid of all these little assets because I think that's just in the way of what my boss fight arena is going to be. And I'm going to drag this start capsule to the back. That is the first thing. There we go. Now, we need a boss. We need a boss. Here we go. As you can see, Paragon Rampage and FX Variety Pack is all there. Nice, that's really cool. So, okay, as I was saying before I got distracted, we need a boss. So let's create a folder called boss. I'm going to change the color to not copy path, set color to blue, just so it stands out and I can click on it quicker. And inside our folder, I'm going to make another folder called blueprints. We're going to have a bunch of blueprints. So let's put them all together nice and organized. You definitely should organize them in folders because we're going to have a lot of assets going around here, like a lot. So make sure to make folders to make it all organized, because otherwise it's going to be a pain finding everything. Right click, find blueprint class, and click on character. Now call this BP_boss. Now, I'm going to call this phase 2 because we're going to have two different boss classes. We're going to have a phase 2 boss and a phase 1 boss. Now, what I'm going to do is I'm going to make a phase 2 boss. I'm going to give it all the functionality, and then I'm going to derive a child from that class and make that the phase 1 boss. And it essentially will have certain features locked behind the fact that it's not yet in phase 2. Now, we won't go too much into it yet because we're not actually going to do it yet. But what we would do is you would right click on it and we'd say create child blueprint class. And let's just call this BP_boss phase 1. Now, what we have done by making this a child class, we haven't duplicated it. We haven't, pressed Control-C, Control-V. We haven't duplicated it. We've made a child class. So if we make an update to our phase 2 boss, which is the parent, it will automatically update that on our phase 1 boss. So if I go into here and I make a variable, let's just call it health. I'll leave it as a boolean. It's fine for now. Go into phase, I should compile and save. There we go, compile save. If I go into class defaults and search for health, you can see that variable. And that's the whole idea, right? When we do something on phase 2, even if the phase 1's already been created, it will still do the update. That's why we make it a child class. So there we go. We're going to go into this phase 2. We're going to go to the viewport. And firstly, I'm going to go to the capsule component. I'm just going to double it. Click the lock for the scale transform and change the transform to 2 on all the axes, just so it's a lot bigger. Because I think our boss, we're going to make our boss a lot taller, more imposing. That's pretty cool. On our skeletal mesh asset, we're going to search for Paragon Rampage. I'm going to put in Elemental. Now there's 4 of them, and these will all work on the same animations. You see, these all have the same skeleton with a different mesh, but they all have the same skeleton, so they all work on the same animations. All 4 of these will work with all the same animations. So if you choose to use a different one, everything in this series will work exactly the same. I'm just choosing Paragon Elemental because I think this guy looks cool for a phase 2, sort of like a fiery vibe going on, but you do not need to use the same one. Just make sure it's a Paragon Rampage one, but you can choose one of the other 4. Set the rotation to -90 on the Z axis, so he's facing forwards, and location to -88, so he's nicely at the bottom of the capsule. Cool. Go back to the level, and we're just gonna place him in, make sure he's facing the right way. There we go. Stand him up. Now we've got our boss, but the boss isn't really going to do anything unless he can see the player, right? Unless the boss can see and detect the player, but that isn't handled exactly in the boss. Now you could technically do it. You could add something called pawn sensing, which is like sight for the boss, but that is quite simple, quite outdated, and frankly it's just not the best option. The best thing to do is to create an AI controller with AI perception. So we're going to do that now, and I will explain what AI perception is. So right click on blueprint classes, then go to all classes and search for AI controller. AI controller, select, put AIC underscore boss. I'm going to actually move this out of the blueprints class because I'm going to make another folder. Sorry, out of the blueprints folder because I'm going to make another folder called AI, and I'm just going to put this control in here, just a bit more organized. Open this up. Before we change anything here, I just want to set it on the boss so it's, you know, connected to the boss and working with the boss. So click on class defaults at the top, go to the search bar and just search for AI. Yeah. Scroll down until you see pawn, and then on auto possesses AI changes to place in world or spawned, and AI controller class changes to AIC underscore boss. Now the controller class, that's pretty like self-explanatory, right? It just means we're using this class. But auto possess AI, you might not know what that is, so I'll explain because it's actually quite an important concept. So when something is placed in the world, it doesn't mean everything and any time it's just been placed. It specifically means it's been placed before the game has started, before runtime has started. So if we go to our blueprints and I just drag this guy into the world, he has been placed in the world. He's not been spawned, right? There's a separate button here which says spawned. That isn't spawned. This is placed into the world. Spawned is when something is added to the world after the game has started or mid runtime. So let's say the game started, I'm running around, we wait 3 seconds, and then imagine an enemy pops up now. The idea is if something is placed after the game has started, if it's spawned after the game has started, then it, you know, triggers this. And this is important because this dictates when is the AI controller going to take control of the boss. So if we just had placed in world, but we decided to spawn the boss after the game has started, which you probably would do if you had a really big game, right? You don't want all your assets instantly spawned. Then the AI controller is never going to take control of the actual boss, so it's never going to do the boss behavior, which is not what we want. So we want to say placed in world or spawned to cover all eventualities, whether the boss has been placed before the game has started or whether it's spawned by a spawn after the game has started. We're going to take control of the boss. And an example of how we're going to use that is we're going to have obviously 2 bosses, one for phase 1, one for phase 2, which they're very similar. But the phase 2 boss, he is going to be spawned in after phase 1 boss has gone to 50% health. We're going to destroy phase 1 boss and then spawn in phase 2 boss. But if we just had this on placed in world, technically the phase 2 boss would never ever be placed into the world. He would be spawned because he's been spawned mid runtime. So he would never be possessed by the AI controller, so it would never work. Yeah. So that is quite important, and I hope that makes sense. I hope we've cleared up what the difference is. Now, on that idea of having 2 bosses and having parent and child classes, they are still, if you make a child class of an actor, it will still be part of that parent class's class in a cast. And that is very important because we need to go to AIC underscore boss, go to the event graph, get rid of those events, and search for event possess or event on possess. See, when this happens, when the AI controller takes control of the boss, we want to pass this to BP underscore boss phase 2. You know what? I'm going to rename this for ease. I'm going to say BP underscore base boss. It is the phase 2 boss, but I think that's more self-explanatory. The base boss, because that's going to be the base. So we're going to search for pass to BP underscore base boss, and then we're going to promote this to a variable, and we're just going to call this boss. It's going to be our boss reference. Now, obviously the cast will fail if the possessed pawn isn't of type base boss, but even if we derive a child class from this base boss, so if we, create child blueprint class and and then have this and try to possess that, it will still work. So we can use the same AI controller for all of the children of this base class, and that's really handy, that's really helpful. So yeah, just once more, because I think this is a really important concept. It's called object-oriented programming, if you're interested. But yeah, if we have a child class, it has all the functionality of the base boss. It's a little bit like copying and pasting the boss to make a new one, but it works with all the same references on all the other pieces of code. And if you change something afterwards on the base class, it is automatically replicated onto the children class. That's a really computer science nerdy explanation. Hopefully that makes sense. If it doesn't, don't worry, because we'll see that in action in later videos. It will make sense later. For now, let's focus on setting up the boss. So the next thing to do is click on add a new component, and search for AI perception. AI perception is senses. It's a way to give the boss an ability to see things, hear things, feel damage, have all these different senses. Because right now, when we walk into the world, the boss right now, he knows nothing, right? He's not getting any updates on anything, which is not good. But if we add AI perception, we can start to give him these senses. Now, it doesn't automatically come with all of them. We have to go to AI perception, go to the senses config, click the plus button, and add AI site config. I'm going to add a second one as well, AI damage sense config. Now, what we've just done is we have now given our AI perception the ability to see things and feel damage. We need to tweak them a little bit. They're not done yet. So if we go into the site config, the site radius is fine, loose site radius is fine. What these are is the site radius is if something is within 3,000 centimeters, so then it will see it. If it's in 3,000 centimeters, it will see it. And then if it walks away outside of a 3,500 centimeter bounds, then it will lose sight of that thing. So if we walk into the boss's vision within the 3,000 centimeters, and then we walk backwards to 3,400, the boss can still see us because he already saw us in that radius. But then if we go to 3,600, he'll lose sight of us, and then he'll have to, detect us again. We're going to change the peripheral vision half angle to 180 degrees. 90 degrees means he can see 90 degrees to both sides, which means he can just see, to the left and to the right. 180 degrees, you can see all the way behind him, which isn't very realistic. He doesn't have eyes in the back of his head, but I want him to be able to do that because it's a boss fight, and I almost want this to be like, I want it to trigger. I don't want you to be able to sneak around behind the boss's back, right? He wants to see you. Detection by affiliation. Now, as a default, our player, I think, is given a detect neutrals class. So we need to tick all these boxes to make sure the enemy will detect us. If you give something a neutral tag and have the neutral box unchecked, then if that neutral is seen, it will be ignored. And we want our boss to detect everything, so we're going to tick all those boxes. This doesn't really make a difference because we're not going to set up an enemy and a friendlies class. We don't want our boss to team up with other bosses, so we want him to see everything and attack everything. So yeah, just tick everything. That's fine. We don't need to change anything else. In our AI damage sense config, that's also fine. I'm going to change the max age to 1. Just so I can explain what it does. We don't actually need it. What max age does is the 1 second in the variable box. It determines how long after this happening does the boss remember that it happened. Now for us, as soon as the boss is damaged, he will instantly go aggro and start chasing the player. But if, for example, you didn't want that to happen instantly, if you're under a small delay, you can wait 1 second and the boss still remembers that it happened. If you put it to 10 seconds, the boss will remember that it happened for 10 seconds, but then after that, he'll forget and it goes away. But yeah, for us, we could leave it at 0. I'll put it on 1 because it doesn't really make a difference. I just wanted to explain what it did. Yeah, very cool. Now we've got a bunch of events down here. And the one we're going to work with, the only one we're going to work with, is on perception updated. And what this does is if any of the perceptions, so for us we've set that to sight or damage, Obviously, if you'd have added more, like hearing, then it would count for more, but we just got sense, sight and damage set up. It's going to take all of our senses, and it's going to see, has any of them, you know, been detected by anything. Like if anything changes on any of our senses, so if the boss has seen something or lost sight of something or felt damage or stopped feeling damage, then this is going to be updated. So what we want to do is we want to do a for each loop to check all of our classes. Check all of the actors that have been, you know, something detected about them. And then we're going to do a sequence because we want to check both of these senses, the sight and the damage, every single time we check an actor. So this is just checking all the actors, if, you know, checking everything we know about each actor that has perception on them. That's a mouthful, but the player, right? Let's just pretend this is the player. We've seen the player. We're going to check if we felt damage or have we seen them. Now, before we continue on this, I need to quickly make a side detour and make an enumeration. So we're going to go back to our boss folder. We're going to make a new folder, call it enums, short for enumeration. Go in here, right click, and just search for enumeration. We're going to call this e_boss senses. Now, I'm creating an enum to hold the different senses we have, which is just, we're going to say sight and damage, because I'm going to make a function which is going to check either sight or damage. Now, for this first time I make an enum, I'll explain what it does, just in case you don't know, but then for future enums, I won't explain what they do every single time. So in an enumeration, it's like an arbitrary list you can create, which essentially just holds strings. They're not classed as strings. It is an enum. It's its own variable type, so don't think it's a string type. But it basically is. It's just a word you can set, and it doesn't have any meaning by itself, but you decide the meaning of what you give it. So let's imagine, right? This is what we're going to do in a couple of minutes. We're going to set up a function which will check an actor's sense. It will either check for sight or check for damage, and we can give it an input of this enumeration, which is sight or damage. Now we could add a bunch more for all the other ones, like hearing or something, but for now we only need these two, and we can do a switch statement. So basically just say, if it's sight, do this, if it's damage, do this. And that's why it's really useful, because it allows you to switch off certain things. And yeah, by themselves this doesn't hold any value, but it's just like a marker for you, the user, for you, the programmer, to be able to, you know, understand things with words, understand the different pins of executions with words. And that might not make sense, and it's okay, because once you've seen how it works, you'll understand it. So let's make a new function in our AI controller. Let's call it check actor sense. Check actor sense. And we're going to give it an input. We're going to give it two inputs actually. The first one is going to be called actor of type actor. And the second one is going to be called sense. Sense of type e_boss senses. Compile and save. We're going to give an output called successfully sensed. This will make sense as we go through and do it. Of type boolean, compile that, save that, go back to the event graph. We're going to put two of them in, and we're going to plug in the array element into both of them. Now, this is how the enum works. In this check actor sense, we can leave that to sight, and in the second one, we can put it to damage, because when we go into the function, we can, this isn't exactly what we're going to do, but for example, we could say switch, and then this gives us a pin to choose which one. So if this is sight, we do this. If this is damage, we do this. It's like doing a massive list of branches where you say branch, is this variable equal to this? If not, is it equal to this? If not, is it equal to this? Etc. etc. It's just, you know, a lot easier to read. We'll just put branches on the end of these. Control D, copy that one. Okay, now let's set up this actual function. Remember, this input, this array element, is the actor that we've seen or been damaged by. So this would be the player if it is the player. If you had loads of things in your game, you could be seeing something else, but let's just pretend it's the player because in our game it's what it's going to be. Let's go into the function. Let's get the AI perception, just drag it in from the components at the top and search for get actors perception. Get actors perception, plug that in. What this does is it gets all the information about a given actor, if we have any. So this actor that we've plugged in, which is going to be the player, we're going to check all the information that we could potentially have about this actor. So we're going to break the information structure so we can see the actual information more clearly. We're going to get the last sense stimuli. We're going to say for each loop, because we could have multiple classes that have been sensed, and we're going to break it. We're going to break this down here, and we're also going to get sense class for stimulus. Now, this is where the enum actually comes into play. This sense class for stimulus, we want to check for a different class depending on what this sense is. So we are going to say equals, and then we're going to say select. Oh, not with that one. We'll drag this over here. So get this sense from the input and search for select. And these like grayed out pins basically mean that they haven't yet been decided, but if you plug it into anything, it will switch to that variable type. So this is expecting a class. If we plug the return value into there, then it's going to take classes for inputs. That's really cool. Now we need to be careful to get this site and damage class right. When you search for site, you see AI site config or AI sense site. The one we want is AI sense site, not site config. The second one here, AI sense site. Very important, you have the right one there. And the next one we want is AI sense damage. Again, you see there's multiple ones. AI damage sense config, AI sense event damage. The one we want, AI sense damage, that's the one that's going to work for us. If you don't use that one, it might not work. In fact, it probably won't work. So yes, be 100% careful to make sure you're selecting the right one there. Yeah, AI sense site, AI sense damage, really important. I've messed that up before and I've spent a lot of time, longer than I'd like to admit, trying to debug what the problem was. So yeah, I just want to make sure you definitely don't fall into that trap. Then we're going to get this successfully sensed from here and plug that into our return node. What successfully sensed means is, for sight, is it us seeing the player or have we lost sight of the player? If we've been damaged, is it the first time we've been damaged or are we forgetting the damage that we've felt? Now in our situation, this won't really make much of a difference because the boss sees the player once and instantly starts chasing them. If they lose sight of the player, it doesn't matter. They don't forget them. They still keep attacking them. It's a boss fight. But just for good practice and just for, you know, modularity, if you want to expand this into a different system, that's very important. So what this function has basically done is we've inputted this actor and we've just checked, are we seeing this actor? If this fires true, we've put in this actor, we've checked this sense for sight, and we've saying, can we see this actor? If we can see this actor, we need to do something very important, and that is an actor has tag. So drag this pin over here and say actor has tag. I'm gonna fill this in and just type in player. We haven't made that tag, so let's go make it. Press Ctrl P to open the assets searcher and search for BP underscore third person character. We're just going to use the character for our person, just to make this quick and easy. The main focus is the boss. Go to class defaults, go to the details panel, search for tag. click on the plus button next to the tag and just Control V, copying the player. If you haven't copied and pasted, make sure if you type it that it's case sensitive and you've done it exactly the same. Don't do, P with a lowercase. If you've done P with the uppercase on the other one, it needs to be exactly the same. It's case sensitive. If it's not the same, all capitals or all lowercase or whatever, it's not going to work. So make sure it's exactly the same. And now we know if it is the player with another branch. We'll do a little bit of logic in a second. I just want to duplicate this. So let's get that, Control C, Control V. Put that branch there. We'll do yoink those, drag them down, connect the pin. Cool. We've only got 2 of these, so it's fine, just copy and pasting it around. Now, what we want to do now is store a copy of this. This is our player, right? We've done all the checks. We've seen the player, or we've been damaged by the player. We know it's a player because they've got the tag. Now we want to store this variable on the boss. So we're going to go back to the base boss and we're going to make another variable, and we're going to call this attack target of type actor. Make it of type actor, compile, save. Go back to AIC_boss. We're going to get the base boss variable we have from before, and we're going to say set attack target. There we go. We'll duplicate this down here as well, and we can plug in these pins. So we can plug in the player variable we have just found and checked that we've properly detected, sensed. Cool, everything's working nicely. Now, the next thing we're going to do is, well, actually, I was going to say the next thing I'm going to do is animation, but we should check this works first. I know it works, but let me just show you how it works. So, in our base boss, we'll just get rid of everything for now. Go to the event tick and do a print. And we're going to print the attack target's display name. If you just plug an actor's pin into a string, it automatically does get display name, which is in this case very helpful. And in the level, when we click play, let's do this first. When we click play, what's going to happen is we're going to be behind this wall and the boss cannot see us. So nothing is going to print on the screen because this attack target variable is going to be empty. But when we walk out from behind this wall into the open, the boss will see us. This AI perception is going to fire. We're going to check all the perception for all the updated actors, which will be 1 because it's just the player he's seen. We're going to check the sight. We are going to successfully sense them. Then we're going to make sure it's a player. We're going to set it as the variable. On here, we're going to start printing the attack target's name, which is BP_third person character 0. 0 on the end because it's the first one. So there we go, play, nothing. There we go. BP_third person character 0. The 0 is just for the index because it's the first BP_third person character. Yeah, that's cool. So now the AI perception is working. Like I said, the next thing we want to do is set up the animations. Now, we're not going to actually have the boss walking around, but we are going to set up the animations for that, so that in the next video, when we do set up the walking and the chasing rather, it will work. This is just like the foundation for that. So let's go to the content drawer, go to our boss, create a new folder and call it animations. Inside the folder, we're going to create an animation blueprint of the rampage skeleton. Now, you'll remember when we were creating our base boss, I said you could choose from any 4 of the skeletal meshes, as long as they're of type rampage. So there was 4 different meshes you could choose from. Now, they all work because they all share this rampage skeleton. So they all use the exact same animations, and they all, so you can take any of the rampage animations and then they all work, even if it's a different mesh. And that's why that works, because there's only one rampage skeleton. This isn't the normal rampage, this is the rampage elemental. But there's no rampage elemental skeletal mesh, it's just, rather skeleton, not skeletal mesh. Here there's just one rampage skeleton. So on the rampage skeleton, create that, call it ABP underscore boss. We're going to open this up. We're going to go to the event graph, and we want to get a reference to our boss from inside the animation blueprint. Now we have the pawn owner, or we have this variable that tries to get the pawn owner, this function that tries to get the pawn owner, but we want to make sure that it is the boss, right? That it is our boss, and then we can get the variables from our boss, such as is dead, and we can transfer them from our boss to the animation blueprint. So we're going to right click and we're going to search for event blueprint initialize animation. We don't want begin play, we want initialize animation. You could do begin play, but this fires before begin play. This is the very first event that does fire, so that's why we're using this one. Then I'm going to cast this to BP underscore base boss. And what this is doing is it's actually doing two things. So not only is it checking if it's base boss, but it's checking if it's valid. Because what could technically happen is this initializes without your pawn owner yet being valid. It's very unlikely. A lot of times you might see people check this with the if is valid statement, but the base boss cast works as well, because it's sort of like the is valid inside it, because the cast fail will also fire if it's invalid. If this fails, we're going to do a delay of 0.2 seconds and put that back into the beginning. Now, the reason we're doing that is because the only reason this will fire is if we've put this, well, we could have put this on the wrong boss, in which case that's stupid and that's a mistake, right? But we're not going to do that because we're smart programmers. Or we might just get, I don't know, some weird bug where it hasn't quite initialized yet. And if it doesn't quite initialize, we want to just make sure we check again in 0.2 seconds, in which case that's plenty of time for a computer at least, where it will have reset and it'll have done that again, and then it now will be valid. So we're going to promote this to a variable. I'm going to call this boss ref. It's not super important. If you didn't understand that explanation, don't worry about it. It's really not that important. Just know we've now got a reference to our boss. We've checked if it's the boss. If it is the boss, promote it to a variable, store that as a reference, and now every time this updates, so like every frame, maybe a bit more, we can now get the necessary variables from over here. Now, I want to get 4 things. I want to get the boss's speed, direction, is in air state, so if they're jumping or not, and if they're dead. Now, all of those except one, we can get very simply from some functions. But the is dead is obviously a custom made variable, so we're going into our base boss, we're going to say b is dead, or make a variable called b is dead, b for boolean, make it of type boolean, compile and save. Then in the abp underscore boss, now we can start doing the variables. So on event blueprint update animation, we're going to search for sequence, and the first thing we're going to get is the boss's speed. So we are going to get this reference down here, and we're going to say get velocity, so we can get the velocity of the boss using this function, and then we can get the length of it. If you get the length of the get vector length, it's not get vector length, it's just vector length. That catches me out every single time. I always say get vector length, but because it's not a variable, it's a function that returns the variable. There we go. So we're getting the velocity, we're getting the length of the velocity, which is just like the magnitude in one direction. This is a 3D variable. Obviously it has, if we split this, not split, break vector, you can see it's got 3 parts. We don't want this with 3 parts, because the reason we need the speed is we're going to make a blend space which will change slightly the animation based off the speed. Now we just want the speed as a unit. we want just to, something like 100 or 200. We don't want an X, Y, and Z value. We just simply want to put in one value, which will, help us know what speed we're going at. You don't want to say, oh yeah, he's going 20 meters per second in the X, 50 in the Y, and 0 in the Z. No. You just want one, you want to say, oh, he's going 10 meters per second, which is why we convert it to a length, which we now can promote to a variable and just call this speed. Plug that in. Very nice. Pull that over here. I'll just comment this and call it speed. We'll add 2 more pins because we're going to get 4 things. The next thing we're going to get is the direction. So if we make a rewrite node down here, to make a rewrite node, I dragged off here. I pressed dot or like the full stop, and it does a rewrite node. You could also search that, just a rewrite node, but if you just press the full stop, it's a lot quicker. So we get the boss reference. We need 2 things to get the direction of something. We need the velocity and the rotation, and with that we can get the direction. So if we search for we can just duplicate this function actually, can't we? Duplicate that, and then we can say get actor rotation, and now we're going to say calculate direction. There's 2. We're going to take this top one under utilities because this bottom one also comes with an extra input of the target. As you can see, this is a target. We don't want it with a target, or we just want it with just the velocity, just the base rotation. We don't care about the target. So we're just going to search for calculate direction again, take the top one, plug in the base rotation, and promote this to variable, call it direction. So now we have, in a simple float value, the direction we're going at and the speed at which we're going in that direction, which is all we need to set up a running animation, a running blend space animation to switch between walking, running, and idling based off of speed and direction, which is very, very cool. We're going to get 2 more things though. We're going to get is in air. So we're going to get the boss reference. We're going to get movement component. Get movement component, and we're going to search for is falling. Not flying, is falling. Promote this to a variable and call it B is in air. Now, personally, I'm not going to make my boss jump. I don't really need this, to be honest. I'm getting it because I think I want to make this a modular system that you can adapt if you wanted to. You don't have to make this into a boss. You could be following this series and just make a normal enemy. So if you want to somehow, add jumping into your thing, then you'll want this variable. I think it's just standard. You have it just in case you want it later. So yeah, is in air. Get that variable. We're gonna get 1 more, and that's gonna be the is dead variable. This works because if we're falling, we know that we can't be on the ground, we have to be in the air, and if we're in the air, we're essentially jumping. So that's how that logic works. Get is dead, get the boss reference again, and you see, this is why I wanted the boss reference specifically and not just a character. If we had just a normal actor, well, with an actor you couldn't, you need a character for this really. If you just had a character, you could get the velocity and the actor rotation and the movement component, because all characters have those things. If you have an actor class, a generic actor, you can still search and get the velocity for it because all actor classes have that. Like it just says here, target is actor. But if we want a class specific variable, we need of that specific class, which in this case is the base boss. So get the boss reference, search for get B is dead, promote that to a variable, is dead, plug that in. Very nice. Boss reference, comment that and just say is dead with a capital. Nice. Compile, save. So the next thing we're going to do, the next big thing we're going to do is actually, use these values to play the animations. But before we can just play the animation, we need a blend space. Now I will tell you what a blend space is, like as we're going through it. So make a new folder, call it blend space, open this up. We're going to search for blend space. Now, here we've got two different ones. There's blend space and blend space 1D. Blend space 1D means you input one variable and you change along a 1D axis, just along the x-axis. And that's not what we want. We want to change based off the speed and the direction. So we're going to do a blend space 2D so we can change our animation based off those two things. Very cool. So we're going to select the rampage skeleton, obviously. Call it BS_boss, blend space _boss. Open this up. Now we have an x-axis and a y-axis, and we're going to input animations onto this graph, and depending on the values, that's going to change and blend between the two animations. It doesn't choose which one's at a specific point, it rather blends between them, it mixes them, it mashes them together and changes them based off of the two variables. So we said speed, didn't we? We said speed and direction. So on the vertical axis, we're going to call this speed. I don't need threes. Speed. Minimum of 0, maximum of 600. 600 just going to be like the fastest speed we're going to go. And on the horizontal axis, we're going to call this direction. Minimum value, not of 0, it's actually going to be minus 180. And the maximum is going to be 180. You see, this character, right? I'll go behind him. He's looking straight forwards. If we go 90 degrees, we've gone here. We're facing the right. We've gone from here to here, 90 degrees. And all the way turning around is 180. And if we go minus 90, we're going here, minus 180 is here. And that might not have made sense, but essentially if you go 90 degrees, you're turning to the right. If you go minus 90, you're turning to the left. If you go 180, you turn backwards. It's not like 90 is one way, 180 is the other way. It's like it's round in a circle, and degrees around a circle, so you have to go minus 180 to 180 for it to work. In the asset browser, we're going to search for jog by head. Jog by ped. I want to take the one on 2 feet. You could use whatever you want, to be honest. At this point, if you have your own animations, or if you want to use the other animations that have come in the rampage, or whatever, feel free to do that. But these are the ones I'm choosing to use. Take the jog biped. That is backwards. We need 2 backwards ones. I'll explain why in a second. So 2 backwards ones at the sides. The forward one goes in the middle. Left goes to the left of the forward one, and right goes to the right. We want 2 backwards ones because if you go 180 degrees or minus 180 degrees, you've still turned backwards. And then we also just want to get idle biped, so it's nice and consistent. By the way, when I'm dragging this onto the grid, now I'm dragging it around, but if I hold shift, it snaps to the grid points. That's how mine's snapping. So as I'm dragging it around, I'm holding shift on my keyboard, and that way it snaps. It's just a lot easier to use. And now, what I was saying earlier with how it blends between the 2 variables is if I hold Control and drag around my mouse, you can see that green thing, it follows my mouse. So wherever this green icon is where on the graph it's taking the 2 variables to mix the animations together and play what it's showing. So if I go just above the walk forwards, he's going to walk forwards. Right here we've got direction of 0, speed of, what is that, 150. But if I turn minus 90 degrees, now you can see he's playing the sideways animation. His feet there, they're going to the side. He's blended. He's not just playing this one because you can go in between and it sort of mixes them together. And that's what's really cool. We're not just playing the separate animations, we're blending them together so we can get any different range. You know, we're not just getting 0 degrees, 90 degrees, minus and positive 180. We're getting 0 degrees, 10 degrees, 5 degrees, 17. We're getting all these angles in between, which we can now walk at and show speeds for. And any speed between 0 and 600 can also be displayed. Now, my graph stops quite early because as soon as my boss gets to 150, I want him to be walking. But of course, you could have a running animation which goes to the top. You can put this wherever you want. It's not at all vital for the tutorial, for the course, for you to have these same values and these same animations. You might want to play around. In fact, I encourage you to play around and try different values, because it's through experimenting and playing around with it by yourself that you'll really learn it and understand it. You know, with this course, you're going to get an idea of how it works, but you're only really going to master these concepts if you go away and try it yourself. If you try and remake it without watching, try and remake it with slightly different values, that will really help your understanding and comprehension of what's going on. So we're going to save this, go back to our ABP on screen, and we're going to go to the anim graph. Okay, I'm going to go to anim graph, and now we're actually going to create our animation states and our locomotion state for our boss. So the first thing we need to do is create a state machine. So right click, search for state machine. I'm going to call this locomotion, but you can call it whatever you want if you want to change something. And what this is going to do is it's going to have a collection of all the different states. So for us, it's going to be idle, running, or just movement. It's going to be dead. We're going to have a state for if our character is dead, and we're going to have a state for is jumping. We're not going to fill in the is jumping state, but I like to put it there just in case, because you know, if this series could be expanded. I mean, I've already done this entire series. As this video is going on YouTube, all the videos are done and all the projects finished. You know, like I said in the series introduction, you can get all of this on Patreon already. It's all done, completed. But you know, if this happened to take off, if people wanted extensions, I would be happy to add in jumping features, add in different extra mechanics. So I want to leave that door open. We get the locomotion. Now I'm going to do one extra thing. I'm going to say I'm going to search cached. I don't remember the function. Okay, yeah, new saved cached pose. We're going to do this. I'm going to call this locomotion again, because imagine I wanted to reference this state machine 3 times, or however many times you want, just more than once. If I just duplicate this, every time I duplicate it, Control C, Control, I don't know why it's not. Okay, it's not copying because it's empty, but if that wasn't empty, let's just add a state. There we go, we'll just call that idle. And I'll go back here. If I Control C, Control V, every time I copy and paste this, I've copied and pasted the entire state machine, which is kind of expensive computationally on terms of resources. But if you instead copy this reference, so if I just search for locomotion, use cached pose locomotion, I'm copying the reference to the state machine. And that's a lot cheaper in terms of computer resources. So in let's get into some programming now. This is a bit more complicated, but I think it's quite interesting to understand. So in C++, when you're programming, you can create something called a reference. Now a reference is simply an integer. It's a memory address, which is just like a string of, not a string, it's a 4-digit sequence of numbers. So I don't know, it might be like 1011, right? That could be a memory address, and it's 4 digits. It's really short, really easy, very, very low memory. So this reference, or you can also use pointers, which are slightly different, but let's stick with references to keep it simple. This reference is pointing to this, you know, to this place, to this state machine. So when we want to copy this reference, we want to copy the pointer. They are different, but I'll use them interchangeably for this explanation. If we want to copy this pointer, we're just copying that 4-digit value, that really cheap, really small piece of information. It's like if you go to a hotel and you want to know the room number and you want to send something to a room, you go to service and you just ask for the room number. They give you the room number, then you can use that to access whatever is at that room location. You don't need to copy the room every single time. And that's why it's a lot cheaper, because here we've copied the entire state machine, but here we've copied this tiny, and this probably isn't just a 4-digit thing, but comparatively it's still a really small piece of information, which is just a reference, or maybe it's a pointer. I don't know how it is back end, but it's pretty much the same thing really, pointing to this location so we can use whatever's at this location. Yeah, and that's kind of a little bit more complex actual C++ programming stuff, but I think, you know, that's a really important concept to understand. We don't go into it too much with blueprints, because when you use blueprints, you don't have an option to make pointer and reference variables. you just make these variables. But if you're in a programming language like C++, you can add these variables as specific pointers and references. And I guess this is a way, it is not explicitly telling you, but yeah, you're referencing something quite useful. So we'll go into the locomotion state machine and let's make the states. Now we've already got our idle state here, but we want to make 3 more. We want to make another state for movement. So drag off, search add state, and we're going to call this movement. We're going to do another state called jumping. So add state, call it jumping. Finally, we're going to make a state for dead. So I'm going to drag off the top of movement, add state, and call it dead. Now I'm then going to drag in idle and jumping into the dead state. So we've got 3 transitions that are all going into dead. And for these 3 transitions here, all of the ones that are going to dead, I'm going to go into them and I'm just going to plug in is dead. Nice and simple, nice and easy. I think that makes sense, right? If we're dead, go to dead. There's no backwards transition because as soon as we go to the death state, we're there permanently. We're in the death state. We're never going to go back. You can't undie, at least you can't in my game. The boss can't. So yeah, just a transition state there. However, for jumping and for movement, we're going to add back transitions. So from jumping to movement this time, so going the other way from right to left, we'll add a transition. Then again from movement to idle, add a backwards transition. In the transition going from idle to movement, so for me is this one right here. Be very careful to make sure you got the right one. From idle to movement, we're going to go into there and we're going to get speed and we're going to say greater than 0. If our speed is greater than 0, we want to trigger this movement blend space. If it's not, we'll stay in idle. So yeah, if we are moving, if we have some speed, go to movement. And if our speed, we'll drag in speed. This is in the other transition, by the way. This is back to idle. In this back to idle transition, we're going to say less or equal than 0. I don't think it would be less than, but just in case, just so we've got all the cases, we'll say less than or equal to. That's set up. From movement to jumping, we will say B is in air, compile and save. Back to locomotion, go in here, we say get is in air, and if it is equal to false, so do an equals, and if it's equal to false, plug it in as a boolean, compile, save. That was back from jumping to movement, by the way. We did keep getting some warnings because we haven't actually added things into our states, but that's fine because we're going to do that now. So in our idle state, we're going to search for idle. And I'm just going to take this idle. Of course, you can use any of these you want, but I'm just going to take this idle specifically because it's the one I used in my completed project, which is on Patreon already. Then in the movement, I'm going to go to my blend space, so search for bs_boss. I'm going to drag in this blend space. Aha, now we can put in the direction and the speed. Isn't that handy? Yeah, we've already made the direction and the speed. It's almost like I know what I'm doing. Okay, we're going to leave jumping because I'm not setting up jumping. I know I added this all in, but I like doing it because then it's like flexible and you've got all the options, and then if you wanted to add jumping you can do. It's quite a common feature, and I'm sure lots of people watching this will add jumping. So if you got jumping, add your jumping here. In our dead state, we're going to leave this empty. We're not going to play our death from here, but this state is quite helpful because when we go to the death state, it's just going to hold our character, and it's like a clean slate for us to play an animation from somewhere else. And we will play an animation from somewhere else, so that's going to be very helpful for us. So if we go to our anim graph, we've got our hashed pose locomotion here. One thing we need is a default slot. So if we drag off of this output pose and search for default slot, we get that very nice. What a default slot does is it means that the animation we're playing is in the default slot. And that's obviously what it is. So let me explain in more detail. We have multiple slots for multiple parts of the body. If I click on the slot name here, you can see a drop down of a bunch of slots. We've got upper body, we've got full body, melee slot, next slot, ability and air shot. There's also, you can have like lower body slots, and a slot is just a specific area on the character's mesh that is targeted by the animation. So you could have a lower body slot, which just means play an animation on the lower body. So for example, in an FPS shooter, you might have like a sort of running animation, but you might only want it to play on the legs so that you can have different reloading, firing, putting your gun away animations on the upper body. So you want to separate the lower and the upper body so you can use different slots to play animations on those slots. So we're putting in this slot just to tell the engine that, we haven't configured anything for specific parts of the body. Just use the default slot, just make it play normally, and then everything is fine. Now, we could plug in this locomotion into the slot and it would work. However, we left the death state open for a reason, and that reason is we're going to play the death from here. So what I'm going to do is I'm going to do a blend poses by bool. So I'm going to drag off of here. I'm going to say blend poses by bool. Now what this function does is it basically says if this variable is true, play this animation. If it's false, play this animation. And we're going to put the locomotion into the false pose because we're going to plug the isDead variable into this active value. And if we are dead, I'm just going to search for death_a. I'm going to plug that into the true pose. So if we are dead, we'll play this animation. If we are not dead, we will play the locomotion. Now, that is it. I'm going to plug this into the end. This is quite a simple setup. As you can see, now the boss is working. That's cool. There's not much going on here. But the focus of this course is state trees and AI behavior. Self-admittedly, I'm not that good with animation blueprints. I wouldn't make a course on them. I don't know them well enough. So there might be extra things you think you might add here, which you 100% can do. This really isn't my domain, because what I want to focus on is state trees when we get to them. Obviously we couldn't do them that much in this video because we have to do all of this setup, unfortunately, but without this setup the course doesn't work, right? We need this basic stuff. Yeah, so just keep that in mind. This animation blueprint setup is very simple, and you may want to, and you definitely should, if you can, add a lot more stuff. If you want to, you might not care. I'm not that bothered. Like a jumping, you might want to actually add jumping for your character. Go ahead. But if you're not going to do that, let's just carry on and let's do the next thing. So we've made the animation blueprint now. We need to use it. We're not currently using it, so we go to our mesh, we go to the anim class, and we're going to search for abp_boss_c. So now if we go to the viewport, as you can see, nice, he's idling. Our animation's working. We're not going to see him walking about yet because we haven't set up any behavior for him to chase the player. But obviously that's coming in the next video, which when you're seeing this, by the time you're seeing this video, that's already done. And you can get them in pre-access on Patreon, all of the videos. But let's just do one more thing in this video. Let's create the state tree. Nice. We're not actually going to add behavior and states to it, but let's create it. Let's create the state tree. Let's talk about it a little bit. Let's just search for state tree. We're on the artificial intelligence state tree, not the gameplay state tree. And now we have two choices. We have the state tree component, just the state tree, or we have the state tree AI component, so the AI state tree. And the difference between these is is the state tree is meant for actors, and the AI state tree is meant for AI actors, also AI controllers and whatnot. But I have found that the AI state tree doesn't really add that much. There's not much of a difference between them. And just because this is called AI, that doesn't mean this other one is not for AI. They're both for AI. They're both, you use both of them for behaviors and states and boss trees. I'm going to use a state tree component, which you might be thinking, why don't you use the AI one? I don't really like the AI one because when I tried using the AI state tree component, I just felt like it was a bit harder to pass certain variables around. And I mean, maybe it's just because I'm more used to using this normal one now, and there really isn't much of a difference between them. Don't go away thinking, oh, there's a massive difference. They're really complex and loads of differences that if you're using one of them, the other one's just completely gone. But yeah, you could use either of these. We're going to use the normal state tree one because it does everything we need. So yeah, I advise you to follow along and use this one. But the AI state tree is an option if you wanted to use that, but you just don't need to. That's the truth, you just don't need it. So that's why I'm using this one. So go to state tree, I'm going to call it st_boss. I'll give it a capital B just for consistency. State tree _boss, we'll open this up. There we go, that's what it looks like. I'm not going to explain anything now. That's going to be in the next video when we really get into it. This was just the first setup video. But yeah, we're going to get real familiar with this real quick. Back to the base boss, we're going to add a component. We're going to search for state tree. We're going to add the normal state tree, not the state tree AI. And we're going to come onto the side where it says AI, go to the state tree tab and look for the st_boss that we just made. Compile, save that, and that is everything. That is this video done. In the next video, we're going to look at how we can make the boss chase the player. We're going to start actually setting up states in the state tree. We're going to delve into how it works. We're going to talk about everything going on here and how we can start making AI do things. And just to recap what we've done in this video, we imported everything into the project. You can see in our content, we've got the FX variety pack, we've got Paragon Rampage. Then we actually made our character. So we created our base boss character that we're going to derive a child class from a lot later in the series. We made an AI controller for him with AI perception, which handles detecting, seeing, or feeling damage from the player. So if we walk into the boss's line of sight, he sets our player to its attack target variable and stores us. We've set up an animation for the boss. So as you can see here, he's in his idle pose. He's just, standing there with his fists on the ground. He didn't do that before. He was like in a sort of T-pose. And of course, next episode, when we add the chase functionality, you will see him walking using the animations we made in this video. So yeah, that is everything. This video was really just setting out the foundation of the series. I know that, this is supposed to be a state tree boss AI course, and we haven't done any of that today. But I promise in the future episodes, we will get into a lot of state tree business and a lot of AI behavior business. It's just we needed to do today's episode because you can't really have a boss fight if you don't have animation set up. You can't do a boss fight if you haven't got your AI controller. We needed these base things. So hopefully you just stuck with it. Hopefully you went through this default setup. Hopefully you learned a little bit about some things. I tried to give explanations where I think explanations are due. But yeah, stay tuned because we're definitely going to get a lot more into state trees in the future. And of course, this entire project is already completely finished. All the videos are finished. By the time this first video comes on YouTube, all the videos are done and on my Patreon. The project files are completed and on my Patreon. So if you want to get early access to all the future videos, if you want to get the project files and all my other project files, I've done climbing systems, crafting systems, inventory systems, loads of stuff. You get them all on my Patreon if you become a member. Yeah, thank you. I'll see you in the next one.